Hello everyone, this is the final presentation for Environmental Health 5102, Environmental and Occupational Health at the University of Arkansas for Medical Sciences. This is my disclaimer slide that this is a student presentation using a hypothetical scenario for educational purposes only. The presenter, myself, is a student at UAMS, not a representative of the agency named in the following slides. The information contained here does not necessarily reflect the views of said agency. My presentation today will be on pharmaceuticals and wastewater. My name is Jacob Siebenmorgen and I'm an environmental health specialist. I'll be presenting to you all my local community consisting of adults aged 55 years and older. Just a broad outline of the coming presentation. We'll be discussing the source of these drugs, where are these drugs really coming from, the specific pharmaceuticals seen in our wastewater, what particular drugs that we use on a daily basis are actually being tested for and seen in our water, why are we currently unable to remove them, why are our large, technologically advanced wastewater treatment facilities unable to remove these commonly seen drugs. Discuss the potential future issues that these drugs might cause, including birth defects, damage to aquatic life, and then eventually antibiotic resistance. We'll discuss some of the solutions for removal, some of the technologies that have been developed to counteract the drugs seen in our wastewater. And then we'll have a slide on decreasing pharmaceutical abuse and increasing proper disposal, kind of some tools for the future to mitigate these problems. So where are these drugs coming from? The most prominent source is the improper discarding of drugs. This includes flushing drugs down the toilet, throwing them in the trash without properly caring for them before doing that. And then obviously with billions of people on the planet and many of them taking large amounts of prescription and over-the-counter drugs, there's going to be a large amount of natural human excretion in urine and feces. And this natural excretion also includes topical medications that wash off in the shower or when you go swimming or something. Large-scale agriculture also contributes to this. As we see factory farms and large amounts of animals gathered in one place, we see increased need for antibiotics and large-scale dosing, and this eventually finds its way into the water system. Healthcare institutions, including nursing homes and hospitals, are obviously going to be seeing large amounts of drugs, and through the natural excretion, through the improper discarding, they eventually find their way to the water system. And then multiple studies have shown that pharmaceutical manufacturing companies improperly dispose of their byproducts and of their drugs. A article put out says that wastewater treatment plants that receive runoff from these facilities can actually have 10 to 1,000 times higher concentrations of pharmaceuticals than normal treatment plants. The image to the right just kind of summarizes what I just said. Eventually, these drugs can find their way to groundwater, surface waters, and unfortunately, drinking water eventually. So specifically, what pharmaceuticals are seen in our wastewater? Well, you might imagine that the most commonly used drugs by people are also the drugs most commonly seen in wastewater. This includes mostly antibiotics and then both over-the-counter and prescription pain medicine. Multiple studies show that there were very large amounts of ibuprofen seen in wastewater. This also includes caffeine, if you consider that a pharmaceutical, nicotine, diphenhydramine or Benadryl, by trade name, anti-seizure medication, including carbamazepine was a big one, and then cholesterol medication, commonly seen in older men, and then hormone medication was another big one, estrogen, progesterone, testosterone. These are very hydrophobic compounds, very water-fearing, I guess you could say, so they will not be degraded very easily by these treatment facilities and really tend to persist in our wastewater. The little chart to the right includes more things than just pharmaceuticals, but it kind of shows the frequency of detection of these common human products seen in wastewater. You can see this includes fragrances like from perfumes, detergents from household use, pesticides from agriculture, and then also included in there is some of the previously mentioned pharmaceuticals. So why are we currently unable to remove these compounds from our wastewater and from our water systems? As I kind of mentioned before, our wastewater treatment facilities in the U.S. are highly technologically advanced. They provide us with great clean drinking water throughout the country. And outside of, rarely seen occasions in Flint, Michigan, we have a very reliable and safe water system. But sewage treatment plants and drinking water treatment facilities are not currently designed to remove pharmaceuticals from our water. They are designed to remove bacteria and toxins from our water through practices such as filtering and chlorination. But these practices that get rid of bacteria and toxins fail to rid all pharmaceuticals. Thankfully, studies do show that these practices do remove some pharmaceuticals. Particularly an article put out by Harvard showed that chlorine, which is commonly used to kill bacteria in drinking water, has shown promise in degrading acetaminophen and other common medications. Another big thing is that treatment plants, water treatment plants, are not breaking any laws when they release this drug-tainted water into the environment because they are not equipped to remove them, and there are no really laws in place that I know of that outlaw any sort of dumping or thing of this nature into our water systems. Little is known about the health effects of these contaminants, and local and national government agencies really have no solid data to refer to in deciding how to control their release into the environment. So all of these contribute to our wastewater treatment plants not having the means and really not having the motivation yet to remove the wastewater or to remove the pharmaceuticals from our wastewater. So as these drugs accumulate, what are some of the potential future issues that we could see down the road? One that research kind of backs is birth defects. Many pharmaceuticals found in wastewater have been found to cause birth defects in animal models. Because this is a relatively new issue, we haven't seen many studies done on humans or long-scale epidemiological studies done on humans. But in animal models, the evidence is pretty overwhelming. Nitrates commonly cause neural tube defects, oral clefts in babies, and limb deficiencies. You commonly hear the commercials, nitrates for chest pain. Nitrates are prescribed for a variety of reasons. Winchester 2009, a paper put out by Winchester, found higher risk of birth defects between April and July. And this is the same time at which there's considerable agrochemicals in the waters. It's where the agrochemicals concentration were at their highest. Now, this obviously is just two factors that we see an upward trend in, so we can't establish this as the cause, but it is an interesting association, and the paper noted the potential for future research in this area. This is somewhat related to everything I was just saying, but birth defects are very common. Every 4.5 minutes, a baby is born with a birth defect in the United States. So we need to do all we can to decrease the cause and potential exposures that lead to these. Another potential future effect is on our aquatic life. This has been well studied. The antidepressants have been found in fish downstream from wastewater treatment plants. Antidepressants is one of the things I mentioned earlier that humans take in high concentrations, and thus is one of the things that's been found in fish. Multiple papers suggest endocrine disruption, so hormonal disruption. Estrogen and other similar compounds have shown to feminize fish, leading to more female fish and more fish with dual sexual characteristics, so both male and female parts. The picture on the right is a picture put out by the FDA that actually shows some of this dumping into a beautiful aquatic ecosystem. So we should minimize these effects because we're starting to already see them in aquatic life, and hoping that we can minimize them before we start to see similar effects in humans. Another potential future effect, perhaps the most prominent, is that of antibiotic resistance. areas where there are increased pharmaceuticals in wastewater show an increased amount of antibiotic-resistant bacteria. This makes sense. The bacteria are exposed to more antibiotics. Bacteria undergo mutations when they're exposed to this, and those with favorable mutations survive and thrive, and that's how we get antibiotic-resistant bacteria, as the picture on the right put out by the CDC shows. This is when bacteria and fungi develop the ability to defeat the drugs designed to kill them. Big problem for future human health. So what are some of the common solutions that we have developed for removal of these drugs from our wastewater? Two that are pretty similar are reverse osmosis and nanofiltration. They both work in similar ways, where pressure is applied to water, pushing it through a very fine membrane to filter virtually everything larger than hydrogen and oxygen, or H2O water. So every large compound, such as pesticides, other agricultural compounds, and pharmaceuticals are filtered out, and we just get pure water. This is pretty hard to do on a large scale, and that's kind of why it hasn't been wide-scale adopted. It's much easier to do for small-scale studies. A 2020 study at the University of Buffalo showed two particular methods decrease the concentration of pharmaceuticals by more than 95%. These two methods were granular activated carbon, also called GAC, or biochar, and ozonation. Biochar is kind of the commonly used term for granular activated carbon, a little easier to say. It's a compound similar to charcoal, which is made from organic materials that contain carbon. So it's made from many recycled materials and other materials that really we don't have much use for that contain large amounts of carbon, and it filters similar to charcoal in other products. Ozonation is where we introduce reactive oxygen compounds to attack organic compounds in our water. So going forward, how can we decrease pharmaceutical abuse and increase their proper disposal? On the front end, to prevent all this, we can really advocate for a change in healthcare practice and an overall reduction in antibiotic prescribing. Antibiotic stewardship is a commonly used term these days. So only prescribing antibiotics when really necessary, and especially not for strains of bacteria that are highly susceptible to developing mutations. And then also just decreasing painkiller abuse and other drug abuse will do wonders for decreasing the amount of the drugs out in our society. We want to limit purchasing drugs in bulk. We want to use drug take-back programs whenever we can. So if we have old medications in the cabinet, we don't want to just throw these down the drain. We don't want to flush them. We want to take them to a drug take-back programs commonly found at hospitals and other clinics around our local community. And then lastly, we can properly dispose of medications in the trash when this is called for. These two pictures put out by the FDA, I understand they're a little wordy, but I really found them very helpful to understanding what you should do if you have extra drugs in your home. So if you have a drug take-back option readily available, you want to take the medicine to the drug take-back location. If not, you need to check and see if the medication is on the FDA flush list. If it is, you can obviously flush it down the toilet. If it's not, then we're going to need to dispose of that in the household trash. This includes mixing the medication with an unpalatable substance such as dirt, cat litter, or used coffee grounds. We're going to place the mixture in a container, such as a sealed plastic bag, throw the container in our household trash, and then scratch out all personal information on the prescription label of our empty pill bottle. And that concludes my presentation. I'd like to thank you very much for your attention, and I'd be happy to take any questions at this time. And if you'd like to, on your own time, you can review my references here at the end. I had quite a few references, and like I said before, there's increasing research in this area, and hopefully we will be able to mitigate the amount of these pharmaceuticals in our wastewater, and also know more about the health effects that we can potentially see in the future.